So with this homework, now I do want you to understand that the problem itself is actually set up to be a 4-step process. Did y'all catch on to what I said with the instructions for the homework? Like, I didn't want you to do a full 4-step process yet because we hadn't talked all the way through it. So I just wanted you to do the part that we had. The first problem is dealing with cholesterol level, yes? Yes, no? Okay. So the first part, all I wanted you to do for part A is you should have done a what? The interpret sentence. So the sampling distribution of X bar is the what? Distribution of, everybody should be saying this, just the same thing. All values of mean blood cholesterol levels for all possible samples of how many? 100 men aged 20 to 34. So that's literally just knowing to fill in what goes there. Questions with that? I think y'all pretty good with that. So part B, you have to know the pieces to be able to do this one. I'm probably not going to write all of it up there. I would write mu of X bar equals mu equals, that's 188. And then sigma of X bar equals sigma over square root n, 41 over square root 100, so 4.1. Are y'all good if I just talk through this and don't write these out?
Yes.
Okay, because I think this part we go through pretty quick. Your upper and lower z values end up being positive, negative, and positive and negative what? 0.73, you get an area of 0.7673 and 0.2327. You subtract them and you get an area of 0.5346. Should be drawn, it should be shaded. You should write the area for both, but I think that's not our concern right now. Now, part C, is this one where it just say different numbers? Oh, just change sample size. Okay. So our mu of X bar is going to stay the same. Our sigma of X bar is now 1.2965, which is smaller because the sample size increases, variability decreases. You end up getting z values of positive, negative 2.31. You end up getting a final area of 0.9792, which is a lot more than it was before because it should be. Because comparing the numbers. Did it ask you a question like?
So like, why would the larger sample be considered?
Okay, and then so it's connecting the fact that the area is more, but what is it really wanting you? The whole connection it wants to make is as the what does what, that part. What's the whole connection it wants you to make? As the sample size increases, the variability decreases. Our mean stays the same, variability decreases, so that's the part it's trying to get there. And tying that kind of into context, like some of you get so into like doing the problem that you're not thinking about it. If you were actually going and doing a statistical project and you had to go interview people, you actually have to make that decision of how many people should I interview to make this work. If you can interview 50 and get by, are you going to have very good results? So like you have to think, okay, what if I double it? How much harder would it be on me? How much longer would it take? Versus how much better are my results going to be? Are some things you would need to think about. Because obviously the bigger sample is going to be better. But if I have to go interview people like door to door, I'm not going to sit there and be like, let me get the biggest possible sample I can. I have to back up and think what's reasonable. So you kind of have to think about both sides of it. 54A, we're starting with our sentence again. Sampling distribution of X bar is the distribution of all values of the mean. And this one wording would be like lifetime of disc brake pads of cars for this particular company. That one's a little bit lengthier. And then the very end is for all possible samples of 8 cars. Maybe more specific cars in this company, is that right? Are we good with this sentence? B, we get, this is a one-sided, it's less than, you end up getting a z value of negative 2.01. Let's get your standard deviation would be like 1,590.9903. And you end up getting an area of 0.0222. You stop there because it stays to the left, so you don't have to do anything. Does that one have a part C? I'll look at this one. Okay. And then 56. What is the difference between A and B for 56? So making sure that the part where it makes a difference. For 56, my part A would say P parentheses what? Greater than or equal to? And what should B say? So make sure that you're making a big point about that you know the difference in which one to write and why. I think I didn't make this point last class. I think I made it in fourth period. So let's say I get to a test and my mind is dead set on this, and it's one of these problems. That should be fine, because what's this going to equal? Which is still going to be the same thing. What does this one equal? So why is that still okay? Because I took one person. So if you get totally messed up, and I always have one person that just gets so stuck of they can't figure out what to put there, it's because it's one and they can't get past that. If it is one and you know it's one, technically going through this process is still the correct thing. I can have the average of that one person and still do it that way. So making sure that y'all do see that connection. We just didn't like start over a whole new equation. Just to get answers for the end of that one, part A, you end up getting a final answer of, your Z ends up being 0.37. Your final area ends up being 0.3557. And then for B, I didn't write it. What do you end up getting as your final answer? 2358. Did we get 2358? Yes, no. Okay, what did we get for, let's just talk through that. What did we get for sigma of x bar? Rounding can make a ginormous difference. So if people are getting different answers, that doesn't mean everybody did it wrong. That might just mean people rounded at different places. So with this one, what did you get as that? And then, so what did you round that to? 0.72? Did anybody round to something different? Because that's going to make a big difference. If you round differently at that point, I'm just telling you, that doesn't mean you're wrong. That just means they're going to be different. 0.712? 721? Okay. So at this point, now we're subtracting. So you get a Z value of what? Which ends up giving you what? So we seem on the same page with that one. We're positive. Which way are we shading? So we have to do 1 minus the end. What do you get when you look up this area? So then 1 minus that gives me what'd you get here? 995 what? Which gives you 0.0043. Do I have any issues there that I need to go back through more? And if you're really close to that, you're probably just off round, you just round a difference somewhere in there. All right, let's get out